Hello folks, this is going to be Advent of Code day number 8, and it's hopefully going to be something relatively light because brain tired, no work anymore. That is the summary of how our day went. Hoping that your day went a little bit better than ours did. That is my sentiment right now. It has been a day because Amazon Web Services had a major outage in US East 1 where about half of the internet lives, and that was unfortunate. The good news is that our service did not go down. The bad news is that it took some heroics to do that, and now we are tired. Hi, Quim. So yes, by the way, hello internet. Yes, we're plural. And the person who normally writes code is currently not available due to extreme exhaustion. So today we're going to meander through how to write software when missing the person who kind of has the core competency at that thing. So, we'll just feel our way through it and see how it goes. And it's not a race, and just going to try to finish it. That's all we can really hope for. But the good news is that at work, one of our values is that we hire adults, and that also means that we trust adults to speak up if they need help. And yes, that even means that we could speak up and say, hey, Christine, our CEO, we cannot do work anymore. We need someone to cover our responsibilities. And she stepped in and she covered our workshop. So we have not, thankfully, been teaching a workshop for the past 4 hours because that would be disastrous. So therefore we've gotten to lie down and get some glucose back in our brain and eat and go on a long dog walk and otherwise try to get the brain working again. Which again does not necessarily mean that the person who is most apt to doing programming is going to be around tonight, but it at least means that, we're not going to fall over suddenly during the stream, because that would be very tragic. Yeah, and the honeycomb values are at honeycomb.io/about, I think so. That seems to be right. Yeah. So it's here. So if you wish to have a look at our values, yes. Number 2 there, we hire adults, and all of us wobble, and being transparent means we can support each other. Very important, and yes. Meant that we were able to get the help today that we needed to not be working for the past 4 hours. In addition to spending 10 hours in a row working incident. Yeah, 10 hours in a row working incident plus 4 hours of workshop would have been not a good idea. But yeah, hopefully people's days were a little bit better than that, and especially hug ups to A9, who is one of the Advent of Code mods and whom we know is an AWS employee, and therefore we hope his day was as okay as it could be under the circumstances. Okay, so Go compiler has been compiled. Wow. Okay, forgetting how to type GoTip version, we were like GoTip run version, GoTip type something. Yeah, not entirely with it today. But fortunately, some of these things are at least a little bit rote. What is GoTip? So Go version is the current version of Go, right? Which Go goes to snap bin Go. And GoTip version no, that's not going to work. You know what? the Googles can explain better than we can. There. The goal of this year's Advent of Code for us has been to learn Go 118 and generics, and therefore, in order to get Go 118 and generics, you have to have the latest Go development tree at least until Go 118 beta is cut. So, hi Viwu. We're glad that you have more energy than we do. You are excited. You seem excited. We are tired. But at least US East 1 is not down while the counter's taking 5 minutes or less. That could be bad. Alright. What were we doing? Oh, right. We were going to copy a day to another day. Today is the 7th, tomorrow will be the 8th. Okay. Might need a little bit more audience participation and help today. This is almost like drunk coding, but worse. If you're drunk coding, you're blissfully unaware of how much you're not making sense. But right now, we very much, very much feel like we would know how to do these things if we were feeling smarter today. Alright, but yes, Twitch plays Go, and you know, that is probably a fair description of what today's stream is going to be like. But we'll see. We'll see, we'll see. Definitely making the, posted this to the Twitter feed today, but definitely making the this is not fine dog tired face. Just like the... But service survived. That's what matters. Funnily enough, the service almost... One of the internal copies of the service almost died after the outage was over, which was hilarious. Which will be a story for another time. Thank you for the hug ups. That is appreciated, Hyperseer. Guess this is also a opportunity to joke about how programmers sometimes joke that they can do a thing in their sleep. Well, this is going to be the equivalent of testing what we know in our sleep. Alright, so there's about a minute to go. Oh, we don't have an input file. We should probably fix that. Okay. Kind of like riding a bicycle. It's a little bit less wobbly the faster you go. That's how we're going to think about it today. But knowing Eric, I know that Eric would know, even if he couldn't foresee that there is going to be a cloud outage today, that tonight is a weeknight. There is probably not going to be, like, a giant mess of a, like, 3-hour puzzle. It might be a 1-hour puzzle, but it is probably not a 3-hour puzzle. But yeah. Hopefully we can finish the puzzle in about an hour. Not caring about how fast other people go, just caring about trying to finish before collapsing into bed. A9 says Eric is a bad name. Man. Also, hi, A9, hug ups to you and yours. You probably had a worse day than we did. Alright, 10 seconds to go, and let's see what happens. Also, hug ups to Eric. I heard that there were some bumps last night after we finished our puzzle, but it didn't impact us. Okay, day 8, here we go. Okay, 7-digit segments. Okay, A, B, C, D. Okay, they're numbered from top to bottom, left to right. Okay. Wires are connected to segments randomly, and they're separate for each 4-digit display. Oh, but all of the digits within a display use the same combinations. Okay. Out of all 10 unique signal combinations, write down a single 4-digit output value. Oh, okay. Okay, we understand. Maybe this will make more sense if we look at the input. Okay, that certainly is an input. Okay, do the standard checks, make sure we get the whole file, because that bit us last year. Yep, Bravo, Foxtrot, Charlie, okay. Okay, but the digits are scrambled. Oh. But even if they're scrambled, the number of them is always going to be correct. Because if there's a 2 segments always means a 1. Okay. 2 segments is always a 1, and that tells you that it's either Charlie or Foxtrot. Oh, okay. So each of the outputs can have at most 4 digits, and they're scrambled the same way in the digits. Oh, 1, 4, 7, and 8 are... Oh, so you just have to count the number of times that those unique combinations appear. Okay, we're overthinking this. We're overthinking this because we just need to look at the second half of the output for now. Okay, that's fine. Okay, so for part A, so we're just going to do this. So we're going to split. Fortunately, most functions in Go are named after the concept that they do, even if we can't type. Okay, and then we're going to look only at the outputs. Are they space delimited? Yes, they're space delimited. Okay. Okay, that makes sense. Okay, so we're going to iterate over all of the words in the output. We're going to call these words for now, just to make more sense for us. The length we can use a switch statement. Switch statement would make more sense here. Okay. So digit 4 has 1, 2, 3, 4. That's awfully mnemonic. Okay. We don't need a default case, that's fine. At the bottom of this, we're going to increment part A. Oh, it's plus plus to increment part A. Okay, that's fine. And what does 7 have? 7 is going to be 3 segments. And then digit 8 is going to be all the segments. 1, 2, 3, 4, 5, 6, 7, 8. Are there 8 segments? Or no, there are 7 segments because it's a 7-segment display. Okay. So this should do what we expect. And I haven't used strconv yet, and I don't expect to actually need strconv today. Okay, let's see whether I got this correct. Yes, that's correct. How am I placing on the leaderboard in this amount of a weird dissociative state? Okay, let's continue onwards carefully. You should be able to deduce the remaining ones. Oh, because once you figure out which one goes to which, you might get nonsense digits if they are not aligned properly. So we have to avoid creating nonsense digits. That's what we need to do. Okay. So understanding that, what we're going to do is this. We're going to go through again, except for this time, we're going to, we have to add all the output values by digit. Okay, that makes sense. How do we even encode this? The order of the letters doesn't matter that much. What matters is which ones are and are not set. So what we think we need is a thing. A thing. We need a thing. Type. Struct. Yes, struct. We need a struct. Okay. So we need a digit, which is going to be a bag of letters, and whether they are set or not. Okay. So then we have what is the length of these? Are these always the same length? They have the same number of letters. It would be better to check this. So this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One of inputs is not equal 10. Okay, and also let's check outputs. There should be 4 outputs per. Let's just check this. Okay. Oh, I see. So you always get all 10. Oh, are all the digits going to be different on the left-hand side? Oh, each entry consists of 10 unique signal patterns, which are going to be the numbers 0 through 9. Oh, okay. Well, that makes that easier. Okay. I can work with this. I can work with this. So in this case, what we're going to have is we're going to have a map from 10 digits to 4 digits. I think I got that right. And we're going to make map of entry, or no, entry is already a map. And then the ordering of these doesn't matter. So let's check this. But that's fine. Okay. Think Go might not let me do this, and that's fine. We'll find out. Okay. Can't remember why we did it this way. Why did we pick runes? Let's keep this straightforward for now. Let's just store these as strings. That'll make our life easier for now. And that way we can replace as we go along or not. Okay, that's fine. We'll make that work somehow. Then okay, let's just make sure that compiles. But we've defined digit to, we've alias digit to string. Does that work? In is not an interface. We're not sure that we understand. Oh, maybe it's like this. Does that work? Too many brackets. Okay, that worked. Cool. Okay. So each entry is independent. So as long as we develop an algorithm for working through each entry, we don't need to consider the other entries. Okay. That helps. So sum starts off as 0. We're going to want to print the sum at the end. Okay. We can methodically work our way through this. This is fine. Left, right, arrange entries. Okay. Okay, so anything that appears in the... So we only need to consider the left parts to create the mapping. Okay. Okay, let's do it this way. So we're going to map each rune to another rune, and then we're going to have a map from string but do we need the number map, a separate number mapping? We do not need a separate number mapping, as it turns out, because I can define this here, like so. I think we can do it this way, because we have the values over here that we need. So for instance, the sorted string, we have to make sure that we sort the strings though. That's going to be important. So for instance, we know that A, B, C, E, F, G goes to the number 0. We know that CF goes to 1. Maps require commas after them. Yes. A, C, D, E, G goes to 2. This is Golang. A, C, D, F, G goes to 3. B, C, D, F goes to 4. A, B, D, F, G goes to 5. A, B, D, E, F, G goes to 6. A, C, F goes to 7. A, B, C, D, E, F, G goes to 8. And now the Go style guide says we have to do that. And last and not least, A, B, C, D, F, G goes to 9. Okay. So we're also going to define a function. Does BE also equal 1? No, BE does not also equal 1 because they all are going to follow this segment format. They are not allowed to look different than that. Okay. Something like this should do that. Thank you, Time Traveler. I got them fairly recently, about maybe 6-7 months ago when it was safe for me to go outside. Before that I needed new glasses, but I couldn't get them. Cars I equals C. Now sort. This one I'm going to have to look up because my brain is not working well enough to remember how to do this. There should be a... Yeah. Slice. Does that work? that takes interface. Oh, I see, but that requires that to be defined, whereas I can just do sort.slice. Okay, that should do it. Be equal to cars index in. No, key is going to be does string join on runes work? Convert between rune array and string. Convert a string to a rune slice. Yes, that's what I want. Oh, in fact, I don't have to do this. I can just do this. That's nice. Convert runes to string. Oh, I can just call string on it. Great. Okay, number mapping of string of cars. Yes. Okay. Okay, that should work. Okay, this doesn't seem so bad. Okay, so I think I understand how to do this now. So basically, okay, so we need to keep track of what numbers we've found, because that's a potential thing that can be eliminated. And we also need to keep track of which ones are not yet recognized. Okay, so something like this should work. And then I'm going to do this so you all on the stream can see it better. So I know at the end of this, what we're going to take is we're going to do something like this. How do we do this? We're going to do it this way. Other way around. No. Other, wait. Oh, that's fine. That's fine. We can work with that. Sure. Okay. So we know sum is going to have the right number added to it. This keyboard here is a Keychron K1. Let me move my prescription record so I don't accidentally dox myself. And let's have a look down here. So yeah, Keychron K1. Okay, what have we here? So, right index Oh, so we need a mapping class as well. Why is our brain not working? Our brain should think, do things. It's not. Today's going to be an adventure, isn't it? Okay. So the decryption key is going to take in a string and return a string. And we're going to do something like this. That should work fine. And okay, I think that should do it. So right index 4 minus -1 minus pause. Is that correct? Because it'll go up to 1 less than, yep, so we want to end on 0, yep. Okay. Does that work? So it's going to... No, but it's 10 to the x, not 10 times x. Okay. So I think something like... Oh. Okay. We understand now. There. That'll do it. Okay. So now we've done this. Now we just need to do the mapping. Okay. So here's how it's going to go. So we can immediately recognize 2, 4, 3, and 7. So we also need a way to fuzzy match, don't we? Let's just see how this goes. So if length of found equals 10, So until we found everything, do nothing. Okay. So I'm going to iterate over each digit from the left-hand side. If what do I mean by positions recognized? Right, the idea was that if I'd already worked a given number, I don't need to consider it again. So in that sense, no, a work queue would be better. Godwo, you're definitely not the only one struggling to comprehend the problem. The problem is a process of elimination where you have to unscramble the wires. The wires are consistently scrambled in each of these blocks of 10 and 4 numbers. It's just that they are not necessarily scrambled in the same order. Okay. So let's think about this. We don't remember why we put positions recognized here. Presents which okay. We know what the wire mapping is because we already have the list here. Okay, yeah, okay. No, this would be better to check this way instead. This would be better to check this way, because then it lets us iterate over the possibilities. So now we iterate over the work queue. So now we can reuse this code here. Okay, now this is all coming together. This is all coming together. Now we're cooking. Now we're cooking. Now we're cooking. Okay. Yeah, now we understand what we're supposed to do. Okay. We got this. We got this. All it took was the brain fog clearing for just 1 second, and now we get it. Do we need a trailing comma on 9, true? Yes, you do. In Golang, it is mandatory to have all of your commas at the end of lines because it makes your diffs cleaner if you reorder things. Okay. So the value is going to be left x pause. So in the event even if we know what the digit 2 is, though, we don't know which order those two segments are in, which could be a problem. Oh, but we can get to that. That's fine. Okay, we understand how to solve this. Okay, so if it's case 2, this is digit. What did our comment say? This is digit 1. So then, missing. And then we know that one of the wires is going to be C, and then the F. Okay. Okay, and we can delete all of these fall-throughs. So we'll do the same for this, and the same for this, and the same for this. So this one will be 4, 7, and 8. Okay. So if it's 4, then this is going to be B, C, D, F. 7 is ACF, and digit 8, immediately know the missing wire is, wait, no. The digit 8 has all of them set. This gives us no information. Okay. So essentially we can partition the wires into, they can either be C or F, or they can not be C or F. Okay, so now we understand. Okay, so this is actually, the decryption key is a little bit more subtle than a rune and a rune. The decryption key actually is going to be if yes, yeah. Okay, so that I'm actually going to make a pointer just to make that easier. Okay, cool. Now I understand how to do this. Okay, so now this takes a list of potential values. Yes. Yeah, okay. Now we understand how to do this. potential values that it could decode to. Yes. Okay. That guarantees one return result, so that's fine. Okay, good. Let's just make this easier to read. Okay. So that's how we track this. Okay. So now, every wire mapping starts off as so now this is better expressed. You know what? Both of these are better expressed this way. Let's do it this way. It sucks to have to repeat this every time, but we'd rather do this once than not. Okay, let's just delete that. Finding things that make your code less readable and making them more readable is good, actually. Okay. So that's populating it now. Okay, so presents the possible set of all from wire to wire. And the beauty of runes is that I can do this. That is going to be a decryption possibilities. Okay, this is feeling like it is solvable. It is a 1-hour puzzle. This should be doable. And we're hardened by the fact that we haven't been rated by another streamer yet so far today. So that means that everyone else is struggling with it too, which is good. Wires could potentially map to themselves, right? Wires connected separately. Yeah, okay. This should be solvable without assuming that it's not itself, and if it is, then we'll deal with that. Okay, and see. Wire mapping index C equals P. Possibilities. Okay. So now we can do this. we're going to need something to work on partial possibilities as well. So, for instance, if I get word that AB should be, that AB should be, what is this, CF, and I should be able to, you can be sure by doing process of elimination. How do we do this? Okay. So these ones are scrambled. See, Golang has index of work. Yeah, index string. This one is an easier case, so let's take care of that first. So, the decryption possibilities, okay. And the delete operation is always safe to do, even if. So we're going to delete from the possibilities the golden character. Yep. Otherwise, we look through every character in the possibilities and delete from possibility C. Okay. Index rune of, oh wait. contains this character. If it does not contain, then we delete. Okay, that looks like that should be logic that works. Cool. Okay, so now and we have up here the number mappings. Should this go the other way? I guess I can reverse the number mappings, it's fine. We'll do it this way. I hate doing it this way, but oh, we can programmatically construct the reverse number mappings and only do it once. Okay, that's fine. Okay, for KV in range number mapping, oops, scrolling up and down too fast. There we go. For KV in range number mapping. Okay, I gotcha, Eric. I understand what you're doing. Yeah, they're scrambled the same way each line, so it is a word jumble. Yes, exactly correct, Hyperseer. So reverse mappings V equals K. Cool. Okay, so now let's change value to scrambled, just to keep my names consistent. Okay, great. Oh. Let's do it this way. That way it'll be clearer. And that'll also, I think, make this logic a little bit tidier. So I can define this in advance. 1, 4, 7, 8. Right, this logic is functionally the same. So let's move that up here. And then let's keep only one copy of this logic here. And then we'll do it this way. One. Okay, yeah, I like it. I like this better. Okay, so what are we going to call this? We're going to call this the mappings. Yep. 4 goes to 4, 3 goes to 7, and 7 goes to 8. Great. Okay. Great. That makes this logic a lot simpler now. In fact, we can just do this. So now that works. So and then What does reverse mappings do? Reverse mappings is the inverse of the number mapping. So instead of calling it reverse mapping, I'm going to call it number to segments. Okay, now that logic makes more sense to me. Hey, welcome, VWoo. Glad that you had fun. We're surprisingly doing okay as we work along at this. Like, we feel like we're making progress, even though it's slow because our brain is not working, like because of the incident brain earlier. Like, this still feels doable. Okay, now, so so if we found a match, we can continue along the work queue. At the end of working through the work queue, we then need to tidy up any... Oh, I see. Okay, yes. So basically, we... where does found get updated? Oh, it's length of missing. That's why that was like that. Okay, cool. Yeah, this is fun. First, we find out whether wire possibilities have been reduced to 1. Then we see if we can learn more digits. Okay. So, hi Anchorini. So first we find out whether wire possibilities have been reduced to 1. So, but does the wire possibility being reduced to 1 help? No, not necessarily. Okay. This is an ambiguous digit. So, let's see, what do we have here? We're going to not record result, but we're going to try to decrypt it to see whether it yields something if we've found exhausted a combination. Okay. This is not record result. This is wire mapping. Okay. Eric, you're saying you like this approach? That's good. We're liking it too. Wire mapping, decrypt of scrambled. If result is not equal to nil, oh, wait, we don't have to necessarily return nil. The reason is we can pass in the list of missing digits. And then that might make it not ambiguous. It's the same thing. Okay. Great. So over here, there's one other way that we can do our decryption, which is this needs to take a list of all the missings. Missing is a map of int to bool. I'm going to swipe that over here. Length of m equals, if length of, oh, I need the reverse number mapping again. That's really frustrating. Okay, fine. We'll do number to segments. Or alternatively, you know what? We'll do it this way. Fine. I hate it, but we're gonna do it. Okay, so 0 goes to 6, 1 goes to 2, 2 goes to 5, 3 goes to 5, 4 goes to 4, 5 goes to 5. Wow, there's a lot of 5s in there. 6 goes to 6, 3 goes to 7, 7 goes to 8, and 6 goes to 9. So there's really only, so there's 2 possibilities for 6. There's this, this, and this. Oh, shit. Right, 6. Number to segment count. Oh, I got this reversed. 6, 7, 8, 9. Okay, so I have to go back and redo these. Okay. 0 goes to 6. 1 goes to 2. 2 goes to 5. 3 goes to 5. 4 goes to 4. 5 goes to 5. 6 goes to 6. 7 goes to 3. 8 goes to 7. 9 goes to 6. Okay, so yes, there are 3 potential values for 6. And there are, yep, okay. Yep, I follow how to do this. Okay, so number to segment count, that's fine. Length of in equals number to segment count index m. Yeah, okay. And count plus plus. If found count is 1, then the decryption we're going to return What is decrypt supposed to return? Oh yeah, decrypt is supposed to return a fully substituted string. So we're going to return the fully substituted string. Oh. Okay. No. Okay, this was unfortunate, and we're not going to do that. Very well. We'll pass a number of segments. I would rather do this than not. Map from to string. Okay, that should do the trick. All right, so let's see what happens. I probably have a ton of syntax errors. Oh, yep. How do I declare a map? Inline. No. Does that work? Surely that doesn't work. I think, okay, I guess maybe I have to repeat myself. Let's try this first. Yeah, no, it doesn't like that. Does that work? Okay, yeah, that does. Great. Except for this is a map int int. Okay, we're getting there. Good night, Viwu. Non-bool used as, oh, I see. Strings index rune, that returns -1. Yep, okay, good. Oh. Okay, found count is equal to 0. Okay, need to import sort. Hopefully there is less intricate debugging because I've hopefully structured my code well. Number to segments. Oh yeah, number to segments of M. That's fine. Okay. This was supposed to. Not sure what's going on here. I'm not sure I follow what you're saying, Hypersphere, but I'm trying to focus on debugging my problem right now. Just going to replace digit with string now that I have this. This doesn't make any sense to do anymore. So where did I have digit before? I might need to get rid of. going to need to no longer need to do this, no longer need to do this. Okay, that should do it. Getting down there. Line 93. Oh, right. Recognize is going to return a number. Okay, 179 and 189 have errors. Oh, yep. And line 189 has an error. Oh, yes. Okay, let's try running that. Okay, that is lowercase decrypt. And where's 179? Can I use star matches type string as delete? Okay. Oh, because this needs to actually be because I changed decrypt to return a string, but really decrypt at this point should be able to operate on recognize. So recognize, so this should now return an int. Okay, what do we have now? We have 85. Oh, string of out. Okay, that's still valid. Yep. And now 188. Okay, so now I'm just missing scrambled, missing, so I can just pass a nil for missing because nothing will be missing at this point, and I can still pass the same number to segments even though it won't be needed. Okay, well, it runs. But it doesn't make progress. So let's find out why we're not making progress now. Oh, because I'm not recording the result. Right, because this here is going to be that. Okay. Okay, so now I still persistently am having 0, 2, 3, 5, 6, and 9 be left out. What's tricky about these? 0, 2, 2, 3, 4, 5, 6, 2, 1, 2, 3, 4, 5, 3, 1, 2, 3, 4, 5, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 9, 1, 2, 3, 4, 5, 6. Yeah, okay, so I'm finding all of the ones that have, right, 1, 2, 3, 4, 5, 6. So what am I managing to identify? Let's print out every time I identify something and why. That'll be more informative than printing out my missings. In fact, I don't need unique segment mappings anymore because this check is now being done. This check here is now being done inside of decrypt, I think. Because if the length of the input is equal to the length of exactly one number to segments, then it should cause us to return that. So I'm actually going to delete this just out of simplicity. Okay, so we no longer... oh, wait. Shit, no, we do still need that. Let's undo that. Number to segments. Shit, did I actually delete it? No, I didn't. Okay, good. Yeah, so number to segments is still there. Yes, that's correct. The thing that I'm no longer needing is unique segment mappings. Yep, okay. Okay. So let's see what results we get. Scrambled to... Okay, so... No, that's not procking at all. Okay, so there's something wrong with my decrypt code now. The thing that's probably wrong with my decrypt is, let's check this. Oh, no, but this is not true because this is not going to recognize it if any of the letters are... out of... No, that should make it exactly match what it's looking for. Number to segments and number mapping. Because recognize should look in number mapping. It should sort it and it should make it look exactly like that. Yep, there's my problem. Okay, so should have returned a recognized value, but it's not. So why is this not returning a recognized value? So this problem is just in my recognize function. Okay, that's easier to deal with. Does sort slice need to return? Greater than, yep, that's fine. Oh, I see the... Yep. Yeah, okay. That's my problem. Oh, that feels bad, man. That feels pretty terrible. Okay. Great. So now Let's make sure that that's working now. Yep, okay, so there's still a bug in here. Recognize found. So yep, there we go. Okay, now this is working. Cool. So I'm finding 874 and 1. But why is it not? We knew that 874 and 1 would map easily. So now the question is our elimination working correctly? The other way to handle this is I might be missing a rule here. Okay, let's take the simple input and see whether I fail on the simple input. Okay, oh no, oh no. Why did these wind up wrapping when I imported it? That is most unfortunate. Okay, well that's fine. That's workable. Okay. Okay, so I am missing a critical rule here somewhere. Oh, I bet what I'm not doing here is I bet I need to update this. Try that. Nope, same problem. Okay, so when I get stuck, what is the status of my wire mapping? Have I deleted the right things from my work queue? Work queue. Just make sure. I think this is going to. Yep. Okay. It's my work queue is always going to contain the same things. Hey Epsilon. Oh no. I'm sorry, I don't want to use a constraint solver. That's fucking cheating. There is no cheating in Advent of Code. There is only cheating yourself. So I know what digits have not been found. That's fine. So let's have a look at the wire mapping. Okay. So the wire mapping has a letter with two possibilities. A letter with two possibilities. Wait, okay, so we know that one of these letters, okay, so there's 1, 2, 3, 4, 5, 6, 7, How many letters should there be in the map? There should be 7. 1, 2, 3, 4, 5, 6, 7. Yeah, that's correct. Okay. Which ones are going to be unambiguous? So once I know both 7 and 1, that should 100% tell me what this one is, because I know that it's the one that's in 7 but not in 1. Is that encoded here? Does my code do this logic? Yeah, that's what I'm thinking about, is comparing the possibilities to known inputs, right? Like, I'm pretty sure I'm doing that, but maybe I'm not. Okay, the other thing, once I have 4 of them done, one, 7, 4, and 8. 8 gives me no information. How do I tell which one is C and which one is F? Oh, I missed one. I missed a constraint, which is the letters at the bottom show up in a certain number of the patterns. Okay, I understand what I have got wrong here. Okay, so this is the other thing. Solved position to count. Right, so here's the thing that I've just figured out, right? Like, so for instance, the character A should appear in 1, 2, 3, 4, 5, 6, 7, 8 of them. Okay, yes, so the problem was not that my solver was wrong, the problem was that I was failing to consider important information. Okay, the letter B appears in 1, 2, 3, 4, 5, 6 of them. And yes, I could automate this, but it helps me to see this at least right away to see whether it's useful. The letter C, 1, 2, 3, 4, 5, 6, 7, 8 of them. Letter D, 1, 2, 3, 4, 5, 6, 7 of them. Letter E appears 1, 2, 3, 4 times. That's unique. Okay. Letter F, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the F is only turned off in one of the patterns, and that's how you tell it apart. Okay. Oh, I understand. Okay. And then the letter G appears 1, 2, 3, 4, 5, 6, 7 times. Thank you, Hypersphere. Yes. Okay. But now that I know that, I'm just going to encode it, because I just know that that's going to be helpful. So let's just do this programmatically so that I don't make any counting mistakes. Segment name to appearance count is make map of rune to int. For number mapping takes the form of a, yep, okay. Okay. That'll do it. Okay, so now, at the very beginning, we're going to need to do this. So at the very beginning, we have all of the values in left. Okay. Okay, so scrambled appearance count, map from room to int. Okay, and I can basically, actually, I already have a mechanism of handling this, which is to record the results. Yep, rune int. It annoys me that I didn't see it for that long, but honestly, it helped me flush out some good bugs before I got to this point. Okay, cool. Okay, for each rune in scrambled, we're going to do scrambled appearance count r++. Okay, so now record frequencies on scrambled appearance count and then the segment name to appearance count, and that should do the trick. Oh, but I can't do that until wire mapping is populated. Unless... Wait, but I haven't populated this yet here. Ah, I see. Okay, great. So, yes. So now, before I record a possibility, I have to make sure that it's consistent. Yes. Okay. So segment name to appearance count and scrambled appearance count. So if segment name to appearance count of P is equal to scrambled appearance count of C, then we can set it as a possibility. Otherwise, it's not even worth checking. Almost there. Okay, 137. Name to appearance count, make rune int. Oh, that's going to be C, not K. Yep. And then line 150. What's the problem there? Oh, make. Okay, now we're cooking with gas. Oh. There we go. Aha! Okay. So that yields the correct result on the sample input. So now let's run it on my real input. Okay. I have a result that looks plausible. Let me remove my debug output. And let's go ahead and run it. I get an answer and add up all the output values. That's correct. Yay! Cool. 90 minutes. Easy. Good game. Just I needed that insight to figure out why it was what I was missing. Cool. So let's go ahead and go format that, and we'll get that uploaded, and we can all go on our merry ways. And also, that was super relieving for sure, to actually be able to recuperate from a nasty day of on-call. So thank you, Eric, for putting these puzzles together. I think this was, despite my wish for an easy puzzle, this was actually surprisingly good. I think I vibed with it pretty well. Cool. Yeah, I think the only changes I might make here are, let's go ahead and let's clean this up really fast, because now that I know that these are unique, I can basically say, where is my unique counter? Right? Did I make a counter of the links? Yeah, whatever. I don't actually care that much. I'm happy with how this worked. All right, successfully recognize all data, and see if we can learn. Oh, the then doesn't matter actually anymore. Cool. Yeah. Okay. I rather like this. I think I did a good job here. Okay. Super fun. Really like this one, Eric. I think that was awesome. All right, this is now pushed to GitHub. You can access it at github.com/lizthegray/admin of code. And yeah, we'll go visit another streamer and see who's still going and cheer them on. And thank you very much for tuning in. Remember to go ahead and check out Honeycomb as a sponsor. If you're watching this, we very much like Advent of Code players. A bunch of us are huge fans, and we think that people who like diving into performance problems will like both Honeycomb and Advent of Code. Cool. See you all later, folks.